Why, hello there. This is Miss Saturian speaking. I am here to fill your wonderful brains with everything about the motion equations that we're going to be talking about in this unit. Here's your essential question. How can I create equations that allow me to find the average acceleration, the average velocity, the distance an object traveled, or the time an object is moving? So the first equation that I'm going to be talking to you guys about is the equation to calculate average velocity. So there's two specific things you have to be able to know in order to actually solve for average velocity. These include the distance an object traveled, or the delta d, or the change in distance, and the time it took for that object to travel that specific distance, or the delta t. Now, I want to point out two things. For short, you can call average velocity v average. And then the other thing I want to also point out is this idea about dependent and independent variables. So velocity, or the average velocity of an object, depends on distance and time. It depends on how far that object traveled. It depends on how long it took. So because it depends on other variables, it's the dependent variable. Now, the other two things, the distance and the time, are independent variables. You can set and actually control those times or that distance that the object travels. So those are definitely things that we're going to want to make sure you have a good idea and understanding of. Now, keep going with this average velocity equation. There's some relationships that we'll be talking about this year in a lot of the equations that we use. So there's this idea that an object, two variables can have a linear relationship. They can have an inverse relationship, or there's no relationship between them. So let's do this one. Let's say you increase the distance that an object is traveling, but its time does not change. It stays the same. So what would the relationship end up being? So this is a linear relationship between the distance an object goes and the average velocity. So what that means is, when something is a linear relationship, if you, let's say, increase one thing, the other increases because of that. Or the opposite. If one thing decreases, the other one decreases as well. So in this example, it's linear. So we can say the longer distance that an object goes, the greater the distance in a very specific amount of time. If they go a higher distance, then that means their average velocity is going to be higher as well. So both of them increase. You can even try doing a sample problem to see how this actually works out with a real life problem. Now, let's say you change a different variable. Now instead, let's increase the delta t. It takes to travel a specific unchanged distance. So it takes you longer to go that distance. That is an inverse relationship between delta t and v average. So what that means is, let's say my time increases to go a specific distance, then that means my v average is going to be lower. So they'll be the opposite. Now, what exactly is the equation? Simple as that. So the v average, the way you calculate it, is delta d divided by delta t. So who cares? Why do these things matter to us? This is why. So an object's velocity, it can be constant, like unchanging, or it could be constantly changing. So this equation will only tell you the average velocity. It's not going to give you a very specific velocity at a specific instant in time. The velocity of an object does not depend on the location or what time it is. So just because it's 3:47 p.m. does not mean that's going to mess with the velocity. And same thing, let's say you're at mile 2000, but you only go 1 mile. And so your delta, did I say that right? Oh yeah, I did. So the delta D would only be 1 mile. So it doesn't matter where you start, it doesn't matter what time it is, that it's a totally different piece there. All right, let's go to acceleration. Now, if you want to know someone's average acceleration, or A average, that's the dependent variable again, because it depends on 2 specific things. How much the velocity changed is one of them, and the time it took, so the delta V and delta T. So in this example, acceleration or average acceleration is the dependent variable, and then the independent variables, the things you can control or can be controlled, are the delta V and the delta T. Now let's talk a little more about this. So relationships, are they linear? Are they inverse? By the end of this school year, you are going to have these relationships down. So look here. If you increase the delta V of an object during a time interval, so you increase the change in velocity, think about it. Would that change the object's acceleration? Would it increase it? Would it decrease it? There's a linear relationship. So that means if I increase my delta V, or my V average, I should say, that's going to make the average acceleration higher as well. So higher velocity, higher acceleration. Now, again, with time, what kind of relationship? So instead, let's say you increase the time it took to change that velocity. What's that going to mean when you try and calculate your acceleration? If you guessed inverse, you are right. So the longer it takes to do something, the lower the V average is going to be. And so that'll make it so that the acceleration is lower as well. So what's the equation? Here it is. So average acceleration, the way you calculate it is delta V divided by delta T. Now, why do we care again? This is why. So if an object is at constant velocity, that means its delta V is 0 because it stays exactly the same. And if delta V is 0, that means average acceleration would be 0 because 0 divided by any number is 0. And so that means the object is not accelerating. Here's the weird thing. It's possible that the object is moving but not accelerating. We'll give you some good examples in class about this, but one I can think of off the top of my head right now is when I am on cruise control in my car, where I am going the same direction on, like, let's say a freeway, and I'm not speeding up or slowing down. So my velocity is unchanged and it's 0, so my acceleration is 0 as well. Summarizing, yay! So let's quickly summarize. Try and talk this over with someone, write it down, I don't know, do something to help you summarize this. How can I create equations that allow me to find the average acceleration, the average velocity, the distance that the object traveled, or the time an object is moving? Have fun!